Hello guys, it is me again and welcome to my class. My name is Joseph AGKLG and tonight our topic of discussion is how to solve future values and present values for other compounding periods. Now, in the examples I have presented before, we use annual compounding period whereby uh, the, the, um, the interest is compounded per year or annually. For example, um, let me see if you can see my screen. Okay, let me share this with you. So if you look at the example, this one here, um, this one here, you can see that say how long would it take for $1,000 to double if it were invested in a bank that pays 6% per year. See, per year. See, that's annual. And in many examples we have done here so far, it says, suppose the risk-free bond promises to pay $2,249.73 in 5 years. If the going interest rate is 6%, 6% per year, how much is the bond want to what today? They didn't tell us how many compounding periods, so we assume that it is annual. So that's what we have been doing so far. However, in reality, the interests are not always compounded annually. For example, we may have different compounding period. Of course, the annual compounding is when the interest is calculated once a year. Now, when you say semi-annual compounding, in this case, the interest is compounded every 6 months. Okay? Every 6 months. So that before you can do the calculation of the return or whatever you're calculating, you must divide the interest by 2 and multiply the number of periods by 2 to show how frequent the interest is calculated. Okay? If the question says quarterly compounding period, that means interest is compounded every 3 months. That means 4 times a year. If this is the case, to do the calculation, whether it is future value or present value, whatever it is, you must divide the interest by 4 and multiply the number of periods by 4 to show the frequency of compoundment. Then you can now use those values to calculate your present value or future value, whatever you want to calculate. Now we have other compounding periods. Can be monthly. In that case, you divide the interest rate by 12, multiply the number of period by 12 before doing any calculations. If it is weekly, that means we have 52 weeks in a year. Then you divide the interest by 52, multiply the number of periods by 52, then use those values. And if it's daily compounding periods, most credit card, as a matter of fact, most credit card use daily compoundment. We eventually come to that. In that case, you divide the interest by 365 and then use it for your compounding and multiply the number of periods by 365. So one thing we need to know again is this is an important fact. So I want to explain it before we start doing our computations. That fact is this: what is the outcome of frequent compounding? Well, I put it this way to you: because interest will be earned on interest more often, then naturally we should expect the higher future values if we must expect higher future values if it is compounded more frequently. In other words, higher future values is the outcome of more frequent compounding. So the higher the compounding period, then of course the higher the future value. That's what it implies. Similarly, you should expect effective annual rate to increase as well with more frequent compounding. Now, virtually all bonds in America are compounded semi-annually, that is twice a year, which means that if you buy a US bond, you receive the coupon payment twice in a year. Stocks in US profits are reported quarterly. So in that case, stocks pay dividends. I mean, for those stocks that pay dividends, most stock doesn't pay dividends. But for matured companies that pay dividends, you receive a dividend quarterly. Mortgage, if you buy a house, mortgage are paid every month, so monthly. Student loan are also monthly. Auto loans, monthly. Credit cards, even though they are paid monthly, they are compounded daily and then averaged for 1 month, 1 month. So, having given you this background, we can now proceed with an example or two. Look at this example here. It says, okay, this is good. It says in the example that, excuse me, gotta make sure. Yeah, the example says, what would be the future value of $28,370 invested now if the money remains deposited for 10 years? The annual interest rate is 18%, and interest is compounded semi-annually. That means twice a year. Then part B say, how would your answer change if it is compounded quarterly? So let me write the numbers down. Then we can go and put them in our spreadsheet. Remember, you can also get this using a finance calculator or formula method. But for this class, we're using spreadsheet. So now, the formula is this: equals future value, then parentheses, interest, comma, number of periods, comma, payment, comma, present value, comma, and then type. This is how you will put it in Excel. So the first one is interest. It says 12%. Sorry, 18%. Now, because it is compounded, semi-annually, so you gotta divide 18% by 2. That gives you 9%. Then, next is number of periods. It says 10 years. Now, because it is compounded semi-annually, you must multiply 10 by 2. That gives you 20. There's 20 compoundments during that period. Next is the payment. There's no payment until the end of the period, so payment is 0. Present value, that's how much was invested. Now, 28,370 was invested. So that means that represents money leaving your pocket. Remember, you must put the sign that will reflect the direction of the cash flow. Money is leaving your pocket, so you gotta be negative 28,370. Then type. You receive the interest, the return at the end of 10 years. So there's no intermediates, not at the beginning. So type will be 0. Now let us go to our Excel and put these numbers in. So I'll take you there to our Excel. I believe this is it. Okay. So before the compoundment, interest was said to be 18%, which is 0.18. Okay. And period of compounding, period before compounding, before you do the compoundment is 10 years. That's what it says. Now let us use the one we're going to use for our calculation will be after compounding. So interest, say it is compounded. If you look at our question, it says that it is compounded semi-annually. That means twice a year, which means, like I explained before, that you must divide the interest by 2. So equals Click on 18 and divided by 2. Okay, in Excel, division is the /. Okay, let's give us 0.09. Number of periods. Give me 1 minute. Okay. Since it is semi-annually, it is compounded. It is for 10 years, but because of semi-annual, but it is 10 years period. But since it is compounded twice a year, so semi-annually, you must multiply it by 10 by 2. 10 times 2. In Excel, the asterisk symbol is present times 2. Okay. 20 compoundments. Payment, there's no payment. Amount invested is 20,000, which is negative 28,000. Sorry, amount invested is 28,370. So negative 28,370. Okay. Since it represents money leaving your pocket, type 0. Now we can calculate our future value. Equals remember that the formula is here. Equals future value, and you put all this in. Okay. So let's go and do that. Put the equal sign first. Future value, FV, opening parenthesis. Like I can see the crate. So we're not using 18% because that is for annual compoundment. We're using 9%, which is semi-annual. Click on that, put comma. For number of periods, we're not using 10 years. Because 10 years represent annual, but we're using semi-annual, which is 20. Comma. Then the rest stay the same. I can see payment, no payment, comma. Present value, which is this one, okay, comma. Future, type. So you can see at the end of the period, 0, okay. Then close the parenthesis and put and click enter, and that gives you the answer. It will be worth $158,997.13, which is the same thing I have here in the PowerPoint presentation. Okay. Now it says, second part of the question says, how would your answer for A change if you are using quarterly compounding? Quarterly compounding. Okay. Now, for quarterly compounding, what you're gonna use is the division by 4 for interest and multiplying the number of periods by 4. Okay, let's see. Let's go and do it on Excel. The good thing about Excel is that when you do your first calculation, you can use it for the formula for the second calculation. It will recalculate it for you. So let me paste it here, and all we have to do is to change the number of compoundment. This one is semi-annual, annual compoundments. This one is quarterly compoundments. So all we have to do now is I want you to looking at these numbers. It will be changing as I change the interest and the number of compoundments. So the interest this time will be equals 18% divided by 4, and I see it changes. Now let's look at the number of compoundments. As the compounding period equals 10 years times 4. Okay, that answer becomes 165,010.26. So you can see that the more the compoundments, the higher the future value, as I stated in my presentation, that because interest will be earned on interest more often, you should expect higher future values the more frequently compounding occurs. Similarly, you should expect effective annual rate to increase with more frequent compounding. So we can see this reflected in our answers here. This is for annual, this is for semi-annual. So thank you for listening, and my next lecture will begin with annuities. Everything we did for the regular compounding, future value, present value. We can do that for annuities. And many people, the investment that a lot of people have, especially the retirement, and even some payments we make, credit card payments, minimum payments, mortgage, insurance policy. There are type of annuities, and there are annuities that can be investment as well. So in my next lecture, we begin with annuities, how to find the future values and present value for annuities. Once again, thank you for listening. And if you enjoy this lectures, please don't forget to subscribe to my channel so that you'll be notified when a new lecture is available. And I will see you soon in my next lecture.